Hello everybody. Today we are going to show how we can use, on a simple example, how we can use generics and traits. For that we will build a structure, a matrix structure, and we try to improve it with this concept. So let's create a simple project. So basically, our matrix is made of items, which are vector. Let's say it's from I64 for now. Maybe command. So it's a two-dimensional array. And we need a size, of course, because let's say it's a square matrix. Zero. And consider we want to add two matrices. So our matrix M will be added to the self-reference. Here we got a brand new matrix. Always say, okay, let's suppose that the sum is our new matrix and will be initialized by matrix new. And that would be the size of, so let's do something like that. For example, size equal we don't need a size parameter because the size will be the size of one of those vectors. The first one, for example, because it's a square matrix. So now we are going to loop over all the items of the element of the matrix and add them to build a new one. Basically, we want something like that. So. And S will be a sum of matrix items. And we look over that. So j in 0 size and of course that should be mutable. Because we are going to change the items, we need the sum matrix to be mutable. And we return sum. And also because our test example will be to create two matrices, and to add them, we probably need something to create a matrix with data from a vector, for example. Let's say we have a size, or maybe we don't need a size as well. We need vector v, which is actually the same as this. And we don't want to own it. No need to own it for that. And we want to create a matrix. Maybe it's like a constructor. It's basically like a constructor. So we want to loop over this and do something the same, but without the sum, obviously. Create the matrix. So maybe it's good. Okay, let's test. And we can create a matrix first. Right. And the vector something like one vector and second vector, and we can simply use simple integer. Well, let's say something very, very simple. There we go. Okay, so we have two constructors and we have add method. Okay, so that's interesting. It's very simple. What if now we decide to have different elements other than i64? And this is where it becomes very interesting. For doing this, we can notice that we need addition of items and we need a 0 element. So let's define a trait. Yes, let's define a trait. Additive group, and we will have add method, and so basically the same signature that we used before. So and then we add another item. So this is actually the add for example, integer, but it could be an add for any kind of scalar, which is basically what we call an additive group, a set, mathematical set, where we can define additions. And we need a 0. Okay, and now what we're gonna do, we are going to try to implement our additive group, the div group for i64. So we want to do that. Element, but because it's i64, it's very simple. Surf plus this simple addition of those. And the 0 is even simpler. Something like that. Here we are. So now we have defined something on additive group. And we say, okay, we want our matrix to use a more general type here. So we could do something additive group, like in Java, but in Rust it doesn't really work like that. We should do something like this, but we put a lot of restriction on this type then. So the way to do that in Rust is to define a generic. And then we will say that t, yeah, put a bound on t. Okay. And we also need to be cloned and clonable, I think. So now what we can do is something like that. We use a 0 here, and here we use, so let's comment it out. Well, let's do it the other way around. It would be the same, but it makes much more sense to me. And this is a reference. Yes, because we defined like that. So this is a way to sum things on our matrix. And because we built one, now we can test if at least the build function still works. Yeah, this is interesting. It's because the type is not precise enough here. So we cannot just guess what would be the type of what we want as a matrix. I64, I64. From back. Oh yeah, I forgot to change that. We need the type T here. And then we have Yeah, in any way it makes sense. It makes sense because we really want to create a real new object. We don't want to borrow any information from the vectors we pass. We just want to create a new matrix from those values. So I think here the clone makes sense, makes a lot of sense. So let's check if we didn't forget anything. Red element, like here. Okay, we can build a matrix, so now we can try to add things. So now we have the sum of the matrices, because there are 2 and 1, it makes 3, 4 and 2 makes 6, and the same here, 3 and 6. But because we did that, we can just manipulate more than integer. We can say we have a complex type, for example. So let's define a complex type quickly. I know that OR exists in Rust already, but for our purpose, we are going to implement it. So we're going to have A plus I, B, something like that. Imaginary part would be B. Okay. So not sure we need a constructor. So we can add complex. So let's say implement complex. And for now, let's implement only the add method. Add method to implement a complex. It will be simple. Actually, it's those two methods, but for now, it's not exactly what we want to do. So we have add method. I will explain. So serve. So the real part will be the formula is quite simple. B plus. So we create the sum of the two complexes. Okay. And now we say okay, we want this type to be part of the additive group. So we say additive group for complex. And now we want to implement those two methods. But keep in mind something. This method is not this one. They are not the same. They look the same, but they are not the same. It's not object-oriented programming. But what we can do here, because we have complexes here, complex numbers, we can just use this method in this one. We can call the complex number method here, doing self add and a reference. So a reference to E, and that will return the object here. Because we own it, because we created it here, we can move it and pass it, return it from the routine. So that should be fine. But what about the 0? So we have the choice. Either we can modify the complex type, and we define a 0 here, and we can use it here. Or we can simply define it here. Float numbers. Okay. So let's create matrix with complex numbers. We will add later, but we can create those. So because we want that, we are going to create some complex number first. Z1. And Z2, something like whatever. And then we can use our complex numbers. But we have to clone them. Okay. I have to make it clonable. We are going to reverse to have some simple case. Obviously, if I don't clone the numbers here, there will be a problem because I could use this one just once and not many times. Okay, we are our matrix. This one. Which is right. Okay, so now we can add M and M2, and it gives a matrix of complex. And this is the same method as before. So the sum is this one. It means, yeah, 4.4, 7.5. Okay, everywhere. Great, so it works well. So what we did, we abstract something, a concept of addition of a type, and we formalize it by creating a trait, additive group, but the matrix must have a generic type T, which is actually an additive group. Any type that will implement additive group. And then in our body, we just use the feature of additive group instead of the own feature of a specific type. That will be more general and more flexible for the future. So this is a good example. It's always like that. When you have generic types and traits, it's always to do this. Just to make things clear, keep in mind that the Rust compiler will duplicate the code for every type you want to use. So in this case, we use matrix I64. It will duplicate all the code of the matrix implementation for this type. And also the same for matrix complex. So your code will be a bit bigger, but also faster, much more efficient, because it can optimize all the routines. For example, the add routine, because this method is known at compile time, the compiler is more capable to optimize. So yeah, this is it for today. I hope you enjoyed the video. See you next time then.